First, measure out required amounts of each reagent according to the lab manual. The exact mass of each reagent is written on the screen, and record them in your notebook. Carefully transfer magnesium turnings into a 10 milliliter round bottom flask. After placing a spin vane into the flask, add 2 milliliter of diethyl ether and a couple crystals of iodine into the flask. In the meantime, please pay attention to the apparatus setup here. Instead of using the drying tube with calcium chloride in it as shown in the manual, a water cooling condenser is used to prevent the evaporation of the reaction solvent, which is diethyl ether. Assemble the round bottom flask to the apparatus on a hot plate and make sure water is running in your condenser before start heating the reaction mixture. Add 1 milliliter of diethyl ether to the vial containing bromobenzene. Then withdraw this bromobenzene solution into a 3 milliliter syringe with a needle. After inserting the syringe through the rubber septum, slowly add the solution to the 10 milliliter round bottom flask in a period of 30 minutes, or all magnesiums disappear in the solution. Please record your observation for this 30-minute period of addition of bromobenzene solution. After 30 minutes, the Grignard reagent has been prepared. Add 1 milliliter of diethyl ether to the vial containing methylbenzoate. Then withdraw this methylbenzoate solution into a new 3 milliliter syringe with a needle. Again, insert the syringe needle through the rubber septum and add the solution to the 10 milliliter flask containing Grignard reagent slowly over 5-minute period. Continue refluxing the solution for another 30 minutes. And don't forget to record your observation in your notebook. After 30-minute reflux, cool down the reaction flask to the room temperature. After cooling down, add about 1 milliliter of 3 molar hydrochloric acid solution to the round bottom flask. And gently stir the solution. Keep adding the acid solution until no more bubbles form and stir the solution again. Add about 3 milliliter of water and stir the solution again. After addition of water, additional diethyl ether has also been added to help layers to separate. Place the biphasic solution on a hot plate and stir the solution vigorously for 1 minute. After 1 minute stirring, their two layers are separated, and then remove the aqueous layer, which is the bottom layer, into a separate beaker. After removing the aqueous layer, gently transfer the organic layer into a 5 milliliter conical vial. Transfer the spin vein into the conical vial as well. Add about 1 milliliter of water to the conical vial, and then wash the organic layer by stirring the solution for 1 minute. After layers are separated, remove the aqueous layer and repeat this procedure one more time. Add about 1 milliliter of saturated sodium chloride solution to the organic layer and vigorously stir the solution for 1 minute, and then remove the aqueous layer one more time. After removing the spin vein, add an enough amount of sodium sulfate to the conical vial and leave the solution for at least 5 minutes. Carefully transfer the organic layer into a 25 milliliter Erlenmeyer flask with a ball and chip. Place the 25 milliliter Erlenmeyer flask containing the organic layer on a hot plate and evaporate some of the diethyl ether. Then add about 20 drops of hexane to the flask and keep boiling the solution. Repeat this procedure until the solution is reached the saturation point for recrystallization. After reaching the saturation point, let the solution cool down for crystallization. Here, as you can see, pay attention to the crystal formation process. After the recrystallization is complete, collect all crystals by vacuum filtration using hexane. Then use additional hexanes to wash the crystals. Then let the crystals dry with the vacuum for at least 10 minutes. After all crystals are dried, transfer to a pre-weighed watch glass and then remove the filter paper and the bowling chip. Determine the actual yield, theoretical yield, and percent yield based on the given data on the screen. Also, the IR and the NMR spectra will be provided on the web campus.